So let's have a look at the changing atomic identity sheet, which a few people are saying they got stuck on. So radium-226 is the first example. It gives off an alpha particle. Radium-226, if you do the calculations, has got 88 protons and 138 neutrons. Now, if we get an alpha particle fired out from the nucleus, that's where it's coming from, it'll take 2 protons and 2 neutrons with it. So that radium will then finish, well, it won't be radium anymore, will then finish with 86 protons and 136 neutrons, which will mean that instead of having radium, we will have 86, which is radon at the end. Okay, let's have a look at question 2. So question 2 is about uranium-235. And if you have a look in your periodic table, uranium has got an atomic number of 92. So uranium, to start off with, has got 92 protons and 143 neutrons. Uranium again is going to fire out an alpha particle from the nucleus, so it means that it'll take 2 protons and 2 neutrons with it. So at the end, we'll finish with 90 protons and 141 neutrons. The mass number will be 231. And instead of having uranium, we'll have thorium. So thorium-231. Apologies for the writing with my fat finger on the screen. Okay, next up we'll have a look at the next one, which is a beta particle. So we've got strontium-90. Strontium-90. Now strontium has got an atomic number of 38. Now when we fire off a beta particle, the mass number stays the same. So this will stay the same. This will go up by 1. So at the end, we will end up with 39 protons, an atomic number of 39. The mass number stays the same, but the number of neutrons will go down by 1. So instead of having 62, we'll have 61. So at the end, instead of having strontium, we'll have yttrium, yttrium-90. So next, let's have a look at the nuclear equations for alpha and beta decays. So the first one's been done for you. We've got beta. You could put some symbols on there, but they haven't chosen to. We'll start with sodium, beta decay of sodium. So let's draw this one out. So sodium 25, 11. So it's got an atomic number of 11, 11 protons, 11 electrons, and 14 neutrons. If it gives out a beta particle, which has got an atomic number of -1, it will gain a proton because we've got a neutron changing into a proton and releasing an electron. So we will end up with the same mass number. The atomic number will go up by 1, which gives us magnesium. And if you notice, to double check it at the end, you can say 11 is 12 minus 1, and you end up with it balancing. Next, we'll have a look at question 16, because I'm bored of doing uranium, so we'll look at californium instead. So we've got californium-249, Cf98, so 98 protons, 98 electrons, and 151 neutrons. Now that'll give out an alpha particle, which has got a mass number of 4 and atomic number of 2, so 2 protons and 2 neutrons, and you will end up with 245, 96, apologies for this being squished in, curium, Cm, which has got 96 protons, 96 electrons, and 149 neutrons. I hope that helps, but give me a shout if you need any more help on this. Thanks.